Good evening all. In last 3 sessions on gravitation, we discussed some of the questions, and today I will explain some more questions from previous examination, previous JEE mains and NEET examination. Some questions I will explain from only gravitation. And from last year JEE mains, totally in the last few years, almost 100 questions are given from gravitation. All the 100 questions are there with us in our book only. But especially in the last year, in 2021, and in the 4 terms examination was conducted, JEE mains examination was conducted. Combinedly in all the 4 terms, only from the chapter gravitation, there were 30 number of questions. Only from gravitation, 30 questions were given only from the last year JEE mains 2021. And some of the questions, some of the models I will discuss today. And one important model was there. Only on that particular model, 6 questions were given in the last year examinations. Of course, last year examination means in the 4 terms, almost 15 to 16 question papers were there. From all the 15 to 16 question papers, 30 questions were given. Out of them, on a single model, 5 questions were given. And of course, that particular model was already discussed in the last 3 sessions. Again, I will just mention those particular questions first. See here. 4 particles, each of mass m, move along a circle of radius r under the action of their mutual gravitational attraction. We discussed many questions based on this factor. What is that? Mutual gravitational attraction. As shown in the figure, the speed of each particle. But the difference is, in all the previous questions, I gave here either 2 particles or 3 particles. But here, 4 particles are given. And all the four particles are moving along a circular path. And of course, the line joining of these 2 particles and these 2 particles, they are making 90 degrees here. Everywhere the angle will be 90 degrees only. Okay, so that means they will just form a square only by combining all of them. So such question is this. And in this particular case, speed of each particle you have to find out. In all the previous models, in similar model of previous questions, how we solved this particular question, I think Aleph remember that the force experienced by gravitational force experienced by any particle due to all the other masses is equal to centripetal force of that particular particle. Okay, so here you have to calculate the force acting on gravitational force acting on one particular mass due to all the other masses. Then that may be equated to centripetal force only. Then you will get the answer for velocity. That is the procedure we followed in the previous questions with the same model. Now, see, I will explain that. See here. First of all, if you want to calculate force acting on this particular mass due to the other 3. So first of all, I will just indicate the force acting on this particle due to this one. Of course, mutual only it is. Let me consider. If the force is attractive, of course, this mass m is attracting that particular mass. And this mass will apply some force like this. And this particular third mass will apply some force like this. And first you calculate. Let me consider 1, 2, 3, and 4. Of course, all the masses are same only. Here you can consider force acting on first mass due to fourth one. This is the force acting on first mass due to second one. This is the force acting on the first mass due to third one. See here, all these forces are not in same direction. If they are in same direction, we can just add them. But here all are in different directions, na? So that you can consider or you can take resultant of these two forces, these three forces. Individually, you have to calculate forces and you have to take the resultant force. That resultant force is to be equated with centripetal force. That is the question. Now, I will solve this. See here. What is the force acting on first mass? Force acting on first mass due to second one. See here, force between these two. You can just see here that this is the angle 90 degrees given here. Then this one is the radius from here to here. And here also this will be the radius. And if there is some 90 degrees angle between them, what will be the value of this particular length of this line? What is the length of this particular line? This is just an hypotenuse for this given triangle. So that what is the length of this particular one? This is root 2r only. If the radius of the circle formed by these particular masses, if it is root 2r, sorry, r, then the distance between two masses will be root 2r, since the angle is 90 degrees there. What is the force formula? And of course, we know that G into M1, M2. Of course, both are same masses, na? So that G into M square by, what is the distance? Root 2r whole square. Root 2r whole square. Then how much it will be? G M square by 2r square. This is the force acting on first mass due to second one. And now force acting on first mass due to fourth one, I will write here. Force acting on first mass due to fourth one. See, here also the similar masses are taken. Here also the distance will be the same, root 2r only. So that you will get here the same answer, that is G M square by 2r square. And how these two forces are? You can simply observe here that these two forces are perpendicular to each other. Force acting on one due to 4, force acting on one due to 2. Both are exactly perpendicular. If two vectors are perpendicular to each other, the resultant will be root over first force square plus second force square. So the resultant of F12 and F14. What is the resultant? Root over. Of course, both are equal only, so I will write F only here. F square plus F square. How much it will be finally? Root over 2F square, which is equal to root 2 into F only. The resultant of these two forces will be root 2F. And F means already we mentioned there, no? That is root 2 into, what is F? G M square by 2r square. Root 2 and root 2 will get cancelled. You will have here only G M square by root 2 r square. This is the force acting on mass due to first and fourth particles. And of course, there is also force due to third particle. Na? That also you have to say. And of course, the resultant of these two will be in this direction only. And F135, now you can calculate force acting on first one due to third one. See, both are masses M and M only. What is the distance between these two? Distance between these two is nothing but diameter, na? That means 2r only. Now you substitute here. G into M square by 2r whole square. This is equal to G M square by 4r square. And this Gm square by 4r square is in this particular direction. And resultant of these two, what we calculated here, that also will be in the same direction. If these two are in the same directions, resultant force will be simply sum of these two only. Now, so finally the resultant force will be, F resultant will be sum of these two. What is that? G M square by 4r square plus, and that one is G M square by root 2 r square. And this is equal to, of course, G M square by r square can be taken common here. What is the remaining equation? 1 by 4 plus 1 by root 2. Okay. So this is the formula for, finally the formula for resultant force. And of course 1 by 4 is nothing but 0.25. 1 by root 2 is nothing but simply 0.71. So finally it will be g m square by r square into 0.25 plus nearly 0.71. It will be 0.96 nearly. So this is the final answer for resultant force. But they're asking here the question, with what speed all these particles revolve? Okay, that means the resultant force only causes the centripetal force. Na? You have to equate this centripetal force with, we have to equate this centripetal force with this equation. So G m square by r square, of course 0.96. Based on the options given, you can write this particular numerical value equal to mv square by r, and of course it is r square, and one m and m will get cancelled, r will get cancelled, and finally v square will be how much then? V square will be 0.96 gm by r. So and v is equal to square root of 0.96 gm by r. That is the answer for velocity of the each particle in this particular given case. Okay. Next one. The similar question I will explain now. The same question again in other question paper of 2021, the similar question was given. See here, 4 identical particles of equal masses, 1 kg, but here it was given the numerical value for mass. In the previous question it was given mass m only. That is only the difference. 1 kg okay. Are you able to listen now? All of you, is the voice clear now? Okay, okay, okay. Thank you. See this question. Two stars of masses m and 2m are taken. They are at a distance d. Rotate about their common center of mass given. That means they are just rotating due to their gravitational force between them only. Because of that, they are rotating. Now the question is the period of revolution is. See here, two masses are taken m and 2m. And in all the previous cases, it was given that those two masses were taken same in the previous cases. But the difference in this question is the masses are different. Total distance is d, and where the center of mass will be, for example, the center of mass of the first one is at the distance of x from small m. And where is the center of mass of second one then? At a distance d minus x only, na? Because the total separation is d given. So from one mass of the distance is x, and for the second mass the distance will be d minus x. Now, while they're revolving because of their mutual gravitation only, now the question is time period of revolution. Try to answer it. Try to answer this particular question. What is the cause for rotational motion here? The cause for rotational motion is only the gravitational force, na? What is the gravitational force between these two? And of course, G into m into 2m by d square. This is the gravitational force between them. That is equal to centripetal force only, na? It is simply mv square by r. But here they're asking us to calculate period of revolution, time period, so that I write here the centripetal force as mr omega square, where omega is nothing but 2 pi by time period. Na? Based on that, I can calculate time period here. Okay, if force acting on mass m is this much, and the centripetal force of that mass m will be mr omega square. Okay, but here r in the sense, what I write here, m into r in the sense distance of mass m from the center, that is center of mass. That means m x omega square. Okay, now you can calculate here. Now you can simply calculate by deriving that. You can just give the answer for omega, sorry, time period. And of course, m and m will get cancelled. And what is the remaining equation? 2g m by d square is equal to x omega square. But x also should not be there. You have to find out the value of x also here. How can you calculate the x value? And if it is the center of mass, if this particular point indicates center of mass, then moment of the two particles remains same only. Na? What is the moment? Mass into distance. So m into x is equal to what we can write here, 2m into d minus x. M into x is equal to 2m into d minus x. Now m and m will get cancelled. X equal to how much then? 2d minus 2x. X plus 2x will be 3x is equal to 2d. What we can write for x then? X is nothing but 2d by 3. That x value you can substitute here. Now 2 gm by d square is equal to x means we can write here 2d by 3. Omega means 2 pi by t whole square. T only you have to find out. Anybody can give the answer for this? Very good. Somebody gave the answer. Good. Most of the students gave the correct answer only. Okay. Solve this to get the correct answer. You have to find out. Of course, 2 and 2 will get cancelled. Gm by d square is equal to d by 3 into 4 pi square by t square. And you have to find out t square only. Na? T square is equal to 4 pi square. D is here. D square will come here totally. D cube by 3 gm. And t is nothing but square root of 4 pi square d square by 3 gm. That is the formula for time period. Okay. Just you see the question here. Two masses, different masses are given and they are revolving about their center of mass. That means the moments will be same only here. So m into mass into distance here is equal to mass into distance here. From that you can just get the equation for x in terms of d. And now the force between these two, the force acting on any particular mass due to the other, that is only the cause for rotational motion. So we have taken the gravitational force is equal to centripetal force. And in place of x, we substituted 2d by 3 and omega can be taken as 2 pi by t. By solving this, you can just get the answer for time period t, which is equal to root over 4 pi square d cube by 3 gm. Okay. Now see the next question. This is also based on the same model. In all these questions, I am doing only one thing, that the resultant force acting on one particular mass is equal to mv square by r or mr omega square. Just I am writing equation for centripetal force. The similar model, on the similar model, 5 questions were given only in the last year 2021. See this question. Consider a binary star system of star A and star B with masses MA and NB revolving in a circular orbit of radii RA and RB respectively. If TA and TB are the time period of stars A and star B respectively, then the relation between them is. In the previous question only we did the same thing. In the previous question, the time period of one particular mass M was calculated here. Even you calculate the time period of 2M, you will get the same thing, because if these two particles are revolving, with two stars, binary star system means two stars which are revolving under their mutual gravitation only. In such case, masses are taken and orbital radii were taken. What we can write? If they are moving only under their mutual gravitation, moments of the two will be same only. Na? Moments in the sense, what we can write? MA RA is equal to mass into distance. For second one, MB RB. Both will be same only. Na? Both will be same here. And because of these two, the gravitational force on anything is equal to G into mass of A into mass of B by distance square only. Na? Whatever the distance they are having, distance square. That is nothing but centripetal force of both of them. That means mr omega square for A, which is equal to, and of course this is the force acting on MA and also force acting on MB. Na? So both of them are equal to centripetal forces. So centripetal forces will definitely be same. So MB RB omega B square. Now MARA equal to MBRB, na? Because they are moving under their mutual gravitation. Then if these two get cancelled, only we have omega A square equal to omega B square. Omega in the sense 2 pi by T. Na? So the TA square equal to TB square you will get. Simply the final answer is, in the options given, TA greater than TB, TA equal to 2B, TB, TA equal to TB, like that. Different options were given. The correct option is, if any two masses are moving under mutual gravitation, their time periods will be same. That is the point here. See, all these four questions were given on the same point. And now come to the next concept. Okay, some more questions given in the 2021 JEE mains only. All are simple questions only. Just you see that, which are in the level of EAMCET only. These are not the difficult level questions which were given in 2021. See the next question. The minimum and maximum distance of a planet revolving around the sun are x1 and x2. If the minimum speed of the planet on its trajectory is v, then its maximum speed will be. See here, I will just draw here some elliptical path only. Okay, elliptical path only. Let me consider, and we all know here that this is the major axis and minor axis for the rotation of planets around the sun. If foci are here and sun is at one of its foci, for example, if sun is at one of its foci, while the planet is revolving around the sun, you can see here that this point, at this point, if planet is, it will have minimum distance from the sun. Minimum distance was taken as x only, x1 only, na? And while it is revolving, if the planet is here, the distance will be maximum. From here to here, the distance can be taken as x2. And minimum distance from the sun to planet is x1, and the minimum distance from sun to planets, maximum distance from sun to planet is x2. And here, if the minimum speed of the planet on its trajectory is v, when will the planet has minimum speed? Whenever it is at large distance only. That means here the speed of the planet will be v, and here the speed of the planet they're asking. That is the question given. I hope all of you understand the question. According to the question given, from sun to planet, minimum distance given, maximum distance given, minimum velocity given. That means where the distance is maximum, velocity will be minimum, and maximum velocity they are asking. While planet is revolving around the sun, which factor remains constant? Because of gravitation between sun and planet only, it is revolving, na? Then which factor remains constant? I think all of you know that angular momentum of planet always remains constant. Okay, so just like when electrons revolving around the nucleus, according to Bohr's rule, angular momentum is equal to integral multiple of h by 2 pi, na? In one particular orbit always, angular momentum remains constant. In the same way here also, angular momentum remains constant. For this one, you see the angular momentum, you try to write the formula for angular momentum, that is mvr only, na? Let me consider mass of planet is m, velocity of this planet which you have to find out, that is v dash, and distance is x1. m v dash x1, that is angular momentum of this planet at this particular point, and that is equal to angular momentum at any other position of the path also. Here, what is the formula for angular momentum? M, there the velocity is given v, and distance will be x2. And of course, in both the cases, same planet is there, na? So that masses will get cancelled, and you have to find out v dash, which is equal to vx2 by x1. This is the question from JEE mains examination 2021. See how easy the question is. The minimum and maximum distances were given, minimum velocity is given, maximum velocity they're asking us. Here we should know the point that while any planet is revolving, which remains constant throughout the path, Angular momentum remains constant. That point we should know here. Okay. Next. See the next question. Very good. Very good. Some number of students are, good number of students are responding online through messages. Very good. See the next question. The masses and radii of Earth and Moon are M1 and R1 and M2 and R2 respectively. Okay, for Earth and Moon, for both of them, mass and radii were given. Their centers are at a distance r apart. Find the minimum escape velocity from a particle of mass m to be projected from the middle of these two masses. This is also a simple question. I will just explain now. See here, for Earth and Moon, masses were given here. Let me consider this is the position of Earth whose mass is m1 and whose radius is r1. And if this is Moon whose mass is m2 and radius was given r2. And their centers are at a distance. The distance between centers was simply given r. And find the minimum escape velocity for a particle of mass m to be projected from the middle of these two masses. But for these two masses, for example, if it is exactly the middle point, that means what is the distance from Earth? R by 2. And what is the distance from Moon? That is also R by 2. So from this particular point, where there is influence of both Earth and Moon, from this particular point, if you want to project a body which can go out of gravitational field of those two, so what is the minimum velocity you have to give? That is the question given. I hope all of you understand this, understand the question. Now, anywhere from any point on the surface or from any point in gravitational field, escape velocity means, to calculate escape velocity, how much potential energy is there at that particular point for the particle. The same amount of kinetic energy, if it is given, then particle can easily escape from the gravitational field. That is the basic point we should know. In the derivation of escape speed also the same concept we use. Escape speed in the sense, escape speed from one particular point in the sense, the total potential energy at this point for the body, how much it is there, that much kinetic energy should be given. That means to calculate kinetic energy or velocity, first we should know here what is the potential energy due to these two. And this is also question given in 2021 August session only. Okay, now see here, what is the kinetic energy here? What is the potential energy at this point due to the Earth? That is G into, what is the general formula for potential energy? G into mass of the planet into mass of the body by R. Of course, minus also will be there. We are equating this now so that I could cancel minus here, negative symbol here. G into mass of the Earth is m1. Let me consider mass placed at this particle is small m, by distance from here to here will be r by 2. And here there is potential energy not only due to Earth, and also there is potential energy due to Moon. So that I can take plus G into mass of the Moon into mass of this object. Sorry, M only, na? M only. By, again the distance from here also will be R by 2. And this total potential energy, whatever you get, that much kinetic energy is to be given. So what is the formula for kinetic energy here? Half m into v square. That v is nothing but escape speed. Now by solving this equation easily we'll get the answer here. Now this can be taken as 2g m1 m by r plus 2g m2 m by r is equal to half m v e square. and m will be cancelled everywhere here, and only you will have 2z m1 by r, 2z m2 by r. I can take 2z by r common here, then it will be m1 plus m2. This m was cancelled. This is equal to half into escape velocity square. And to calculate the escape velocity, v e square is equal to 4g by r into m1 plus m2. And finally, ve is equal to square root of 4g by r into m1 plus m2. Well, if you understand this, this is also very much simple question. From which point you have to calculate escape speed. There you have to calculate total potential energy, and which should be equated to total kinetic energy. That's it. Okay. Now, next question. See the question then. See the question here. All of you try to answer this question. A mass of 50 kg is placed at the center of uniform spherical shell of mass 100 kg. Okay, and radius 50 meters. If the gravitational potential at a point 25 meters from the center is V, then the value of V, you have to just calculate gravitational potential only. A spherical shell is taken here, whose radius is given r. Of course, it is given 50 meter. And what is the mass of this particular spherical shell? 100 kg. The mass of spherical shell is given 100 kg, and a 50 kg mass is placed at center of this one. At the center of the spherical shell, 50 kg mass is also taken. That means two masses were taken. One is the point mass, other is spherical shell of mass 100 kg are taken. Now the question is, if the gravitational potential at a point 25 meters from the center is V, that means from this particular point, center to this one, if it is 25 meters, at this point P, let me consider, you have to calculate gravitational potential. See, how can you calculate that? Anybody can give the answer for this? Okay, try to give the answer for this. What is the gravitational potential at this point due to 50 kg? 50 kg is simply a point mass only, na? For simple point mass, what is the formula for gravitational potential? For point mass, potential due to point mass. What is the formula for that? Simply root minus g m by r. That is simply minus g into, what is the mass here? 50 kg. Point mass is 50 kg, by what is the distance from here to here? 25 meters. That means 25 2s are 50, so it will be minus 2z. That is the potential at this point P due to this 50 kg mass, which is point mass. But there is also a potential due to spherical shell. Inside the spherical shell, we know that already I explained in the previous classes. Inside the spherical shell, gravitational field intensity will be zero. Which will become zero? Gravitational field intensity will be zero. When gravitational field intensity is zero, potential remains constant, because potential is nothing but minus integral E bar dot dr bar. If gravitational field intensity is zero, potential remains constant. Constant in the sense, whatever the potential is there on the surface of the shell, the same potential it maintains at every point inside the shell. In case of shell, what will happen to the potential? Whatever the potential is there on the surface, the same potential it maintains at every point inside the surface. So potential inside the shell. What is the formula? Whatever there is potential on the surface, simply minus G into same formula m by r only. What is mass of the shell? 100. On the surface, what is the distance? 50. So 52z. This will be also minus 2z. That means potential due to point mass, potential due to the shell at any point inside, which is equal to potential on the surface. So this is minus 2g, this is minus 2z. Then what is the total potential at this point? Total potential will be sum of these two only, minus 2z, which is equal to minus 4z. Based on the basic concept of potential only, the question was given. Okay. Now, see the next question. The satellite is launched into a circular orbit of radius r around the Earth, while a second satellite is launched into a circular orbit of radius 1.02 r. Then the percentage difference in the time period of two satellites. Just the percentage only they're asking. See here, what is the relation between, simple question. This one is also very simple question. EAMCET level question only it is. So what is the question here? The relation between time period and radius is given. What is the general relation between time period and radius? I think all of you know that. D square is proportional to r cube. But they're asking here in terms of percentage. And it is very much less value. Change will be very much less only. So I can write with the error formula, I can write 2 into delta t by t is equal to 3 into delta r by r. And finally, you have to calculate percentage difference in time period. Na? That means delta t by t is equal to, you can write 3 by 2 into delta r by r. You have to calculate percentage change. That means delta t by t into 100 you have to calculate, which is equal to 3 by 2 into delta r by r into 100. See here, what is change in r value here? One is 1.02 given, 0 to r given, one is r given. What is the difference? Difference is simply 0.02 r by r into 100. Then this will be r and r will get cancelled. This will be 0.02 into 100 will be 2. 2 will get cancelled, and answer is simply 3%. Here the percentage change in time period will be 3%. See how simple questions are given even in JEE mains examination. Just on the basic formula only the questions are given. Okay, see the next one. See that simple question only I gave. Try to answer it. The time period of satellite in a circular orbit of radius r is t. The time period of another satellite in a circular orbit of radius 9r is. So same relation between t and r. T square is proportional to r cube. Two different cases were given. Na? That means t1 by t2 whole square is equal to r1 by r2 whole cube. Here, what is given? Initially time period is t given, radius is r given. Finally, radius is given 9r. So you can, time period is t given initially, t2 you have to calculate, whole square is equal to r1 by r2. That means r by 9r whole cube. R and R will get cancelled. This will be 1 by 9 whole cube. Okay. Now, by solving this equation simply, by taking square root on both sides, t by t2 is nothing but 1 by root 9. Of course, whole cube also will be there. 1 by root 9 will be 3 only. Na? So 1 by 3 whole cube, which is equal to 1 by 27. Then t2 will be equal to 27t. By solving this simple equation, you will get time period in the second case will be 27t. See the last question. See the last question here. The radius in kilometer to which the present radius of Earth to be compressed so that escape velocity increases 10 times. Mass will be same only, radius only is to be compressed. What is the relation between escape speed and radius? I think all of you know here that escape speed is nothing but root over root over 2 gm by r. How it depends on r? It is given only compressed. Mass does not change. So VE can be taken as 1 by root r. Here two cases are taken so that you can write V1 by V2 is equal to root over R2 by R1. Now, in the first case, what is the escape velocity? Just you can consider V. V or V1 you can write. And escape velocity is increased 10 times. That means V2 will be how much? 10 V1, which is equal to root over R2 2 by initial value is r. Now, so 1 by 10 will be r2, 1 by 10 will be root over r2 by r. Na? By squaring on both sides, you will get here 1 by 100 is equal to r2 by r. 1 by 100 is equal to r2 by r only. Then r2 will be how much? R by 100. So the radius of earth is 6,400 kilometers only, na? By 100. So answer is simply 64 kilometers. They are asking in terms of kilometers only, na? So that answer is 64 kilometers.